Hello and welcome to the relationship section of the National 5 video tutorials. Today we're going to talk about simultaneous equations and using substitution to solve them. Alright, to solve this pair of equations by substitution, what we're going to do is we're going to take what x is equal to in the second equation, which is y minus 2, and we're going to substitute y minus 2 into the top equation every time we see an x. So that will make it become 2 times y minus 2 plus 3y is equal to 31. Then what we need to do is we need to expand out this bracket by multiplying through by 2. So we get 2y minus 4 plus 3y is equal to 31. If we combine our y's, we've got 2y's here and 3y's there. So we're going to combine them to make 5y minus 4 is equal to 31. Add 4 onto both sides. This gives us that 5y is equal to 35, and we should be able to tell from that y is equal to 7. Now that we have our value for y, which is 7, we're going to substitute that back into the second equation. So the second equation becomes x is equal to 7 take away 2. And I hope I don't have to tell you that 7 take away 2 is equal to 5. So our final answer to this simultaneous equations question is that x is equal to 5 and y is equal to 7. Okay, here's a second example. In this example, y is equal to x minus 5. So what we're going to do is we're going to substitute in x minus 5 everywhere we see y. So this first equation becomes 5x take away 2 times x minus 5 is equal to 37. Right, we're multiplying through the bracket by a negative number this time, so it's a little bit more tricky. We start with our 5x just like before, and then minus 2x, and minus 2 times minus 5 gives us plus 10, and that's equal to 37. Okay, all I've done there is I've multiplied out the bracket. And the next part of this is to add our x's together, or in this case take them away. 5x take away 2x is 3x plus 10, and that's equal to 37. Take away 10 from both sides of the equation to keep it balanced, and we get that 3x is equal to 27, and that makes x equal to 9. Okay, if x is equal to 9, and then we can substitute that into the second equation to figure out what y is equal to. We get y is equal to 9 take away 5, which is 4. Okay, so our final answer to this simultaneous equation using substitution is that x is equal to 9 and y is equal to 4. Okay, now that you've seen a couple of examples yourself, here are 4 for you to try. Make sure you pause the screen now because the answers will be revealed in just a couple of seconds. There you go, so your first example, you should have got that x was equal to 5 and y was equal to 6. For your second example, x is equal to 5 and y is equal to 3. For your third example, x is equal to 3 and y is equal to 1. And for your fourth example, x is equal to 7 and y is equal to 10. In some examples where you are using substitution to solve your simultaneous equations, you need to rearrange the second equation so that it is either in terms of x or it's in terms of y. At the moment, this equation is not in terms of either, so we want to make either x or y the subject. I'm going to choose x for this one. So if I take y off both sides of the equation, I get that x is equal to 13 take away y. We can now use this substitution into the first equation to give an equation in just one variable. So we're going to change all the x's into 13 take away y's. Alright, same as before, we're going to multiply out our brackets. So we get 39 take away 3y plus on 2y is equal to 31. if we do 3y take away 2y, 3y add on 2y, we get minus y is equal to 39 minus y is equal to 31. If we then take away 39 from both sides, we get that minus y is equal to minus 8, and that means that y is equal to positive 8. Okay, so we've got our value for y. We now just need to substitute it back in to our second equation. I'm going to substitute it into this version of the second equation. So we get that x is equal to 13 take away 8, and x is equal to 5. So our solution to this simultaneous equation is that x equals 5 and y is equal to 8. Here's one that's slightly more difficult. We need to rearrange the second equation again. My first step for that is I'm going to divide everything by 2. So I get x plus y is equal to 11. And then I'm going to take this in terms of y this time, just for a change. So I'm going to get y is equal to 11, and I'm going to take off x on both sides and get minus x there. Okay. So our first equation is going to look like this, where we replace all the y's with 11 minus x's. Multiply out the brackets, so 2 times 11 is 22, minus 22, minus 2 times minus x gives us plus 2x, and that's equal to, that's equal to 34. 5x add 2x makes 7x, minus 22 is equal to 34, and then we are going to add on 22 to both sides in order to solve this equation. So we get 7x is equal to 56. If 7x is 56, then that makes x equal to 8. So we're going to substitute this back into our rearranged version of our second equation. We get y is equal to 11 take away 8. Y is equal to 3. Okay, so our final solution for that one is x equals 8 and y is equal to 3. That's how you do simultaneous equations questions where you have to change the subject. Okay, now that you've seen a few examples, here's a couple for you to have a go at yourself. Make sure that you rearrange the second equation so it's in terms of just x or in terms of just y, and then use your substitution to solve the simultaneous equation. Okay, I'm going to give you a couple seconds and then the answers will be revealed, so make sure you pause the video now. Okay, so your answers are as follows. For question 1, you should have got an answer of x equal to 4 and y equal to 5. For number 2, you should have got x equal to 9 and y equal to 5. For number 3, you should have got x equal to 8 and y equal to 1. And for number 4, you should have got x equal to 9 and y equal to 5. And that concludes the video on substitution in simultaneous equations. Thanks for watching.